Good morning, ladies and gentlemen. Today it's already very humid and hot, and I think we're feeling the impacts of climate change every day. And the Consortium of Satellite Earth Observation has initiated a series of workshop and symposium to deepen understanding on climate change and moreover to link various stakeholders to address this issue and to advance contribution of Earth observation satellites. And we are proud to have stellar speakers on this issue, and we're very excited to have you all. And thank you for all for your participation, especially and for online participation as well. My name is Naoko Sugita, and I'm from Earth Observation Research Center and Secretariat of CONSEO, and serving as your MC today. And before jumping in, I would like to mention several housekeeping issues. So if you have questions, especially those who have questions online, please feel free to put it on the chat box, and we may be able to pick up several of them if we have time. And also, this session, unfortunately, will only be in English, but we will provide Japanese summary later after this event. So for the sake of time, I would like to, without further ado, I would like to jump into this session. First, I would like to ask for the opening remarks of Mr. Hironori Maejima, Senior Chief Officer of Earth Observation Missions from Japan Aerospace Exploration Agency. So, Mr. Maejima, you have the floor.
ありがとうございます。おはようございます。私、JAXA の前島と申します。Okay, so good morning, everyone. I'm Hironori Maejima, Chief Senior Officer of Earth Observation Missions of JAXA. And thank you for joining the Climate Change Series event organized by Satellite Earth Observation Consortium, or also known as CONSEO. Let me briefly introduce CONSEO and the Climate Change Series program. In Japan, the development and application on Earth observation satellites have traditionally been led by public institutions and academia for scientific research and development purposes. However, recently, there has been an increase in space-related startups and ventures, along with growing private investment. Companies from non-space sectors are also entering the field, leading to active engagement in the private space. To address social challenges and achieve sustainable socio-economic development, space activities, including satellite Earth observation, must also become sustainable. This requires building a new space ecosystem where private companies drive innovation and collaborate with public and academic sectors. To realize this vision, JAXA established CONSEO 2 years ago. Today, it has been grown into a co-creation community with over 250 companies and academic organizations from various fields. Leveraging the diverse partnership between industry, academia, and the government, CONSEO has planned the Climate Change Series program. Climate change is causing more severe disasters worldwide, affecting biodiversity and infectious disease issues. To tackle these complex global environmental problems, it is essential for individuals to deepen their scientific knowledge of climate change, generate ideas to solve the societal issues, and take action through partnership. Understanding Earth's processes and crucial to addressing the enormous challenges of climate change. However, the Earth's environmental system is complex and not fully understood. Long-term global collection of various environmental data is necessary for this understanding. Additionally, addressing such global challenges cannot be achieved by the science and technology of one country alone. International cooperation is essential. For effective climate change mitigation and adaptation actions, we must continuously work based on scientific insights derived from the understanding Earth's processes and accurate future projections. Under the partnership of the industry, academia, and the government, I sincerely thank Dr. Saint Germain, Director of NASA Earth Science Division, and Dr. Tsunami, President of Sasakawa Peace Foundation, and Dr. Nakamura, Deputy Assistant Minister of Ministry of Foreign Affairs, for graciously agreeing to speak today despite your busy schedules. Through discussion with these distinguished experts, we hope to deepen our understanding of the significance of Earth observation for climate change measures. Thank you.
Thank you, Dr. Maejima, for the opening remarks. Now I would like to move on to the next speech. So next, we would have outline of the consortium on satellite Earth observation climate change series. It will be presented by Naoko Matsuo. She has been leading this initiative. She's a senior administrator for Satellite Applications and Operations Center from Japan Aerospace Exploration Agency. So Naoko-san, you have the floor.
Thank you, Sugita-san. And good morning, everyone. Thank you for joining today's event. It's the first event of CONSEO Climate Change Series. So I'm Naoko Matsuo, a senior engineer of JAXA Satellite Application and Operation Center, and I'm leading a JAXA Secretariat team of CONSEO. So I planned this series event. So that's why I would like to talk about the outline of this event. So very briefly. Next, please. I think all of you feel that something has happened on the Earth. So in Mecca, 1,300 people lost their lives due to heat wave. And I heard the news of flooding in Dubai, Middle East. So I couldn't believe my ears. So global climate change is not future problem. So it is happen now. So we have to address the climate change. So to address these global issues, so we plan the CONSEO Climate Change series. So we have to learn from various perspectives on Earth's environment. And through participation in this event, so we hope to deepen your scientific knowledge on climate change and generate ideas to solve the societal challenges and take action through collaboration among industry, academia, government, and international partners. Next, please. So far, I planned various activities such as workshop, symposium, seminar, and working group to discuss how we use the satellite data to solve the societal issues like disasters. So thanks to these activities, CONSEO members are more interested in climate change. So that's why this year we would like to focus on the climate change. And the CONSEO Climate Change series has three purposes. The first aim is to emphasize to the government about the importance of international cooperation to understanding and addressing the climate change. So I know Japan has a capability to get new findings about the climate change, but it's still complex issues. So international cooperation is very useful to try the mitigation and adaptation on climate change. And the second aim is to share the latest scientific research to the CONSEO members. So it leads that industry members will create or get new applications addressing the issues on climate change. And the third aim is to raise the awareness of Earth observation satellite. So maybe you know the role or importance of satellite Earth observation, but people don't know how the satellite Earth observation contribute to understanding climate change. So I would like to share it to the public. And next, please. And we planned a sixth event of climate change series. So it is still under planning. So if you want to know something, so please let me know. And next, please. And today is the first in a series focusing on climate change and the international cooperation. So experts will speak and discuss various perspectives. As a keynote speech, Dr. Saint Germain, Director of Earth Science Division of NASA, will talk about the Earth science research to understand the Earth processes and the implementation of its results. And the next, Dr. Onoda, welcome back to Japan, and the Director of International Relations and the Research Department of JAXA will talk about the trends in global climate change. After that, the three panelists will speak in climate change dialogue. So Dr. Saint Germain from NASA and Dr. Tsunami, president of Sasaka Peace Foundation and chairman of CONSEO, and Dr. Nakamura, Deputy Assistant Minister of Ministry of Foreign Affairs. So they will discuss the response to humanity's climate change challenges and Japan's role. So from each perspective. So thank you for your attention and please enjoy today's event. Thank you.
Thank you very much, Matsuo-san. So as you see, we are trying to address all diverse stakeholders in the coming month. So I hope you keep to be engaged in our initiatives as well. So now I would like to ask. We're very excited to have Dr. Karen Saint Germain, Director of Earth Science Division, NASA, for a keynote speech. You have the floor.
Thank you. Good morning. What an honor it is to be here with you. First, this is my first real exposure to CONSEO, and let me congratulate you. It sounds like a fantastic initiative, and I think as I go through my presentation, you'll find that we are thinking about things in a very similar way. So I'm very excited to be here to speak with you today. All right. Let's see if this should be animated. There we go. What you're looking at on this slide is NASA's Earth Science Fleet. Probably similar in Japan. In the US, when most people think of NASA, they think of astronauts, they think of going to the moon, they might think of rovers on Mars, or maybe a space telescope like the James Webb. What they don't know is that the planet we study the most is our home planet. And this is our fleet. Many of these individual missions are specialists. Some of them are generalists, but it's together that they give us an unprecedented view that you can only get from space of our home planet. This is another way of looking at the fleet. So we call this the swoosh. On the outside, you'll see year. That's year of launch. So the missions in green and blue are on orbit and operational. The missions in gold and lavender are in various stages of development. So one thing you may notice right away is that some of these missions are very old and approaching retirement, but we're excited that we have new missions in the pipeline. And one of the challenges is balancing continuity or sustainment of observations with innovation and new observations. It's not called out on this chart because it would be too messy, too busy, but many of the missions on this chart, even though I call them NASA missions, many of them have very strong international partnership. So you will see them on other countries' fleet charts as well. And we're very proud that we take this global approach. The urgency, we heard a few words about the urgency, and I just want to show you one way of understanding what is happening in the global climate. You're looking at global temperatures as a function of month of the year for each year since we started constructing these records. This is a product called our GISTEMP, and it tells a dramatic story of the warming of our planet. And I'm just going to pause here and let you watch this because it is striking. You're looking at temperature anomaly, so departure from the average. So you can see that temperatures are warming year by year and warming in every month of the year. So we need, the next generation of missions must have technologies, better temporal resolution, better spatial resolution, to better inform our science so that we can adapt and mitigate this change even as it's underway. The idea is not just to survive, but to continue to thrive on the planet, even in the face of such change. Normally, oh, there we go, the fish are swimming. Normally, when we think about climate change, we think about land, life on land. And that makes sense because that's where the humans are. That's where we live. But this year, NASA is focusing on our oceans. We are a water planet. 70% of or so of the Earth's surface is covered by water. And yet it's safe to say that we know more about the surface of the moon than we know about our own oceans. Understanding the role of oceans in climate change is essential. Understanding how the oceans absorb and move excess heat, how much longer the oceans can continue to absorb that heat. Today, the oceans absorb 94% of all of the extra heat that's trapped in the Earth system. Think about that for a moment. Think about the effects we're seeing on land today, and that's with only 6% of that excess heat left in the system beyond what is absorbed by the oceans. And also the biology of the oceans. When we think of removing carbon dioxide from the atmosphere and creating oxygen, you and I think about planting trees on land. Well, the biology of the oceans contributes just as much to that process, and understanding how the oceans might help us mitigate climate change is just as important. So I'm going to talk about the oceans for a couple more minutes. This animation is one of my favorites. It comes from the VIIRS instrument, and it's showing you life on Earth. On land, of course, you see the familiar in the spring, the greening, the growing of plants and crops. And in the winter, you see the snow and the ice. The same process happens in the oceans. In this depiction, the areas that are green and yellow are where there is a lot of life at the surface of the oceans, phytoplankton. The areas that are the deep purple, those are areas that have very little life in the oceans. And that's because life in the oceans requires really the same three things that plant life on land requires: carbon dioxide in the atmosphere, sunlight for photosynthesis, and nutrients. On land, plants get those nutrients from the soil. But in the oceans, those nutrients come mostly from one of two sources. It can be runoff from land, minerals running off into the oceans from land, or they can be upwelled from the deep ocean. Sometimes, and we have seen this, they get precipitated out from the atmosphere. But the life on the oceans is essential for understanding how the planet works. This is a look at the physical oceanography of the oceans. This is a model output showing you how the currents and the eddies. It's very slow moving, but I find it mesmerizing. The currents and the eddies in the oceans, this is important to understand because I mentioned that much of that excess heat is being absorbed by the oceans. Most of that is happening close to the equator, in the low latitudes. It is the oceans that move that heat around the planet. And if you want to understand the changing weather patterns, weather starts in the oceans, all of it. So we have to understand the oceans. And we're very excited because just in the last 2
10,
years,
9,
we launched
8,
2
7,
new missions.
6,
One
5,
called
4,
SWAT
3,
and one called
2,
PACE.
1. Booster ignition. Full power engines and liftoff of the Falcon 9 and PACE, helping keep pace with our ever-changing ocean and atmosphere.
NASA, go for SWAT launch.
Launching stage 1 propulsion is nominal.
Sound.
9, 8, 7, 6.
Okay, that's enough fun. So in 2022 we launched SWAT. That is the product of over 40 years of collaboration with the French space agency CNES in ocean altimetry, and then in this past February we launched PACE. SWAT is intended to tell us about the physical oceanography. PACE is intended to tell us about the life in the oceans. This is a global view of the data from PACE. What you're seeing here is sea surface height anomaly. So red is 25 centimeters, blue is minus 25 centimeters difference from the average. This is, I think it's the first 21 days average of SWAT. And it's the first ever view we have of global elevation at this spatial resolution. Let's see, I think, does this animate? No, I guess not. I thought it did. So SWAT is a Ka band radar interferometer, and it precisely maps the global water bodies at 2-kilometer resolution. Oh, it's going. Yay. Okay. And what you can see here is a level of detail that at first you might think, I thought the oceans were kind of flat. They aren't. All in those areas where there are currents and eddies, those change the elevation at the surface of the oceans, as does the bathymetry, the shape of the bottom of the oceans. So these features are real, and they are telling us about, of particular importance, the upwelling and downwelling features of the ocean, which we think play key roles in both ocean biology, the transport of nutrients up and down in the oceans, and the transport of heat up and down in the oceans. So this is, it's still early days in working with SWAT data, but these are stunning new results showing us our oceans in a way that we've never seen them before. Making sure I'm saying everything I'm supposed to say. Okay. This was I just like to show this one because this was the first light image we saw, and what you're seeing there in the red is the Gulf Stream at a level of detail that we have never ever seen it before. And now we're going to move on to PACE. PACE is going to profoundly advance our knowledge of the ocean's role in the climate cycle. It's a trailblazer mission in ocean color and atmospheric science, and it promises the most advanced study of our aquatic ecosystem to date. PACE was conceived principally as a means of measuring ocean color for assessing large-scale ocean health using innovative technologies. The ocean color instrument is the only hyperspectral ocean color instrument sensor capable of providing daily global coverage of high quality ultraviolet to shortwave infrared hyperspectral data. That is a mouthful. We call that instrument OCI, and the OCI measurements will provide data to determine the distribution of phytoplankton, those tiny plant-like organisms. You may know them as algae. That sustain the marine food web. And of course, there are many different kinds of phytoplankton. The green that's visible from space is chlorophyll. That's the usual thing that we're used to seeing, and it's the essential pigment responsible for photosynthesis in all plants. There are two other instruments on board PACE that provide global polarimetry measurements to investigate the role of aerosols in our aquatic and atmospheric systems. And PACE is examining some areas of largest uncertainty in our climate system, including the role of aerosols and clouds and the interaction between the oceans and the aerosols and clouds. See, there we go, another animation. So this is a swath of true color imagery as the spacecraft passes over each location. And then we're going to zoom in here to the southeastern coast of the US and show you several data layers, including, this is chlorophyll A. So this is, again, something that you're used to seeing from many similar instruments. But what we can do from PACE is determine different communities of phytoplankton. This is important because some phytoplankton are delicious, delicious fish food. They're really important for our aquatic or our marine economy because they feed the fish that drive our fisheries and so forth. Other types of phytoplankton are toxic. Some to fish, some to humans, some to both. We really want to understand what species are where, and the hyperspectral data from the PACE Ocean Color instrument will reveal these different communities for the first time. On top of that, the aerosol sensors will tell us a lot about aerosol composition, size, concentration, height in the atmosphere. All of those attributes of aerosols are very important to understanding what kind of clouds will form from those aerosols and how those are related to the oceans. So I think that was my last oceans highlight. Now, standing on the shoulders of those two great ocean missions that have just launched, we're now looking forward to the next series of missions that we are building. We call it the Earth System Observatory. These are the major components. And this collection of missions was guided by our National Academies of Science. And, and designed to accelerate our understanding of how the whole Earth works as a system and accelerate our ability to use that information. I'm going to speed up a little bit because I think I'm running short on time. So we have just recently released NASA's new Earth Science to Action strategy. This is where you'll start to see some similarities to your concepts in CONSEO. So at the base of the strategy, the foundation is our core capabilities, the ability to launch missions, to observe the Earth system, to develop the technologies that we need to do that better, do it faster, and do it more affordably. So all of those technologies and the space missions and the data from those are in that foundational layer. But when we have that, we can build up. We can perform the research that increases our understanding of how the system works and how it is changing. And we can develop applications so that we can make that understanding useful for people who have decisions to make. Those applications, that understanding moves up to solutions and societal value. So putting those answers into the hands of people who need them, when and where and how they need them. And then, just as you discussed just a moment ago, increasing the public understanding and confidence in what we know, how we know it, what steps they can take, and key to all of this is transparency. All of this is done with tremendous partnership. There's international partnership throughout this pyramid, particularly with strategic partners like JAXA and the European Space Agency. There are partnerships with our other US agencies that provide services, and there are partnerships with the private sector. And of course, university academia research is also throughout this strategy. So how does this work? NASA's role is what you're looking at here is the value chain of going from observations all the way to use of data and then evaluation of how well the data is being used. NASA's role is heavier on the left side of this value chain, but we have to have those interconnected links all the way through this value chain. And this is something I present this as though we figured it all out. We have not. We are still working on this very much with our agency partners, with our international partners, with our commercial partners. But this is the idea, that there is a value chain and everyone has a role throughout, but the weight of those roles varies. We have relationships with our other US agencies. I think this is very similar to what you do here, to make sure that the observations we make and the science and the applications are feeding the work of all of our other agencies, including disaster relief, agriculture, air quality, weather prediction, and so forth. What's happening here? I don't know. Oops, hang on. Got ahead of myself. So one of the ways that we do this is by providing tools that look like this. This one happens to be a sea level rise tool. So it's openly available on the web, no matter where you are. You can click your location. This one is tied to the IPCC report. So you can look at different IPCC scenarios and find out what that's going to mean to you in your coastal community where you are. As you saw earlier with the SWOT data, sea level rise is not uniform, and very much not uniform along our coastlines. All right. I think we're coming to the end game. So let me close talking about GPM. So I'll just use one of our shared missions with Japan to illustrate the value of international cooperation throughout this whole process. This week, we are celebrating 10 years of the Global Precipitation Mission. Japan's contribution to this mission includes developing one of the prime instruments aboard GPM's core observatory, the dual frequency precipitation radar. This dual frequency precipitation radar provides three-dimensional observations of rain and helps improve the accuracy of the rate of global rainfall. Japan's contribution, and I said this yesterday in our discussions with your ministry, with MEXT, the collaboration between NASA and JAXA and the GPM mission, it was good for both agencies. It was good for both of our countries. But most importantly, it was good for the world, because this gives us the first global understanding of precipitation. Using this technology, GPM aids humanity and our shared scientific exploration of the planet's Earth system in many ways, advancing our understanding of Earth's water and energy cycle, improving forecasting of extreme events and natural hazards and disasters, and accurate and timely information on rain and snowfall. One fairly recent example was Hurricane Freddie. This visualization shows how GPM's capabilities are monitoring and studying tropical cyclones around the world. Surface rainfall estimates with the passage of Tropical Cyclone Freddie across the Indian Ocean from February to March of this year. We're showing Freddie because this is, Freddie broke the record for the longest lived tropical cyclone. And so what you're seeing here are precipitation estimates of every 30 minutes. So, there's a lot of detail, and I think I'm out of time, so we can't talk about the specifics in this case, but this was an incredible storm. It was incredibly persistent, and I think we're going to see more of that as our oceans warm. We'll see more tropical cyclones. They'll decay as they always have, but in this case, it came back. It re-strengthened, and we're going to see more of those kinds of events. So, the applications that GPM supports are critically important to people at every scale to make decisions related to not just severe weather and tropical cyclones, but also water management and farming, natural resource and ecological management, public health, disasters and risk management, energy infrastructure, and weather, climate, and land surface modeling. This, by the way, this NASA-JAXA partnership extends back to 1987 when the first studies were initiated, and TRIM, the first mission we worked on together, was launched 10 years later. So GPM is the follow-on to that, and we are now working on the development of the atmosphere observing system to continue this collaborative work into the future. So I think I better get off the stage, but I just want to end on a note of optimism because climate change is a daunting challenge. But we are seeing that more people than ever are turning to science to help manage the challenge. And science-informed decisions are better decisions. And we in this room all know that there's an enormous difference between the best possible outcomes ahead and the worst possible outcomes ahead. It is our job to help our communities get to the best possible outcomes from here. And as my colleague Steve Voles says, we are the champions of hope. Thank you.
Thank you so much, Dr. Sandra, for your very sharing the latest developments and findings. It was visually so helpful, and also the message was such an encouragement for us to work us together. Thank you so much. So now I would like to ask Dr. Masami Onoda. She's Director of International Relations and Research Department at JAXA, but today she would report as a member of the Global Future Council for Space of the World Economic Forum. So, Dr. Onoda. ありがとうございます。はい。How much time do I have? 10 minutes. Okay. Okay. Yeah. So
Today, as Naoko-san kindly introduced me, I'm here, of course, as the former JAXA Washington, D.C. rep, but also as the current International Relations Director at JAXA, but also as the member of the World Economic Forum, widely known as the organizer of the Davos conference, always in winter, in Switzerland. They convene, I think our prime minister most of the time appears there. Most of the heads of states come there, and many business leaders gather in Davos to discuss the state of the world's economy and then where we are going. And I think today my objective purpose of being here is to just give you an idea from a different perhaps perspective on how the world sees space and Earth observation specifically, and to give some insight on how we may address this from a little bit of a different perspective of economy that I think today would be very persuasive, especially to policymakers and the wider industry. This one. So the way, I'd probably get this from my computer as well. Just a moment. Yes. So before going into this, since I'm told I have 2 minutes, yes, I will explain a little bit about, so what about, World Economic Forum and space? The World Economic Forum, of course, doesn't suddenly have this heads of state meeting in January. They have a group of experts, about 1,000 or so today, I think, who are from various fields, especially of cutting edge technology, including space, but also AI, quantum, fusion, all of these kinds of new areas that the World Economic Forum feels that influences economy. And so there is a group of people called the Global Future Councils. About, I think, 40 or 50 exist now, and out of one is the Global Future Council for Space. And here it was just, I think, established about maybe 10 years ago or so, and we have about 40 members that are selected by the World Economic Forum, and NASA, of course, is there, the European Space Agency also, but mostly also industry people from space are there, and the chief economist of NASA is a member. And we discussed there in the beginnings a lot of space sustainability. We established what was called the Space Sustainability Rating, which rates companies according to their activities, assessment of the rate of space sustainability they are achieving. So that was in the initial output, and now we're coming to Earth observation. These 2 years or so in the current term, the World Economic Forum sees a lot of potential in the business and economy by Earth observation. So what I'm going to introduce now very briefly as an introduction, so you can delve in later on, because there's a lot of content, what the World Economic Forum, in collaboration with Deloitte, has done in the past years. So they have conducted, mostly using Deloitte as a workforce, they have conducted a series of hearings and literature studies, and also economic modeling into finding some initial thoughts that is summarized here, understanding both the business value and climate and nature value achievable through Earth observation data is critical to making meaningful progress towards sustainable future. This may be quite apparent to us, but we have to recognize we're a very small community here. And there's a whole industry out there that does not even know what Earth observation means. It does appeal very much to them, just letting them know this is happening. Earth data components, remote sensing in situ, this is also very clear to us, but this is a finding that we're trying to message. When it comes from the World Economic Forum to decision makers, it has a whole different impact than us saying what we're doing. It's great. Awareness, economic value, governance and policy, technical, all these implications and Earth observation value chain components going into our society. This is the way the World Economic Forum sees the impact of Earth observation. How do we use Earth observation data? So they went into all use cases, which is very, very, extensive, and we can use this probably each of the countries, like Japan can probably adapt it to our own strategies. There's a lot of content in how Earth observation data is used in economy. And they go into use cases, agriculture, construction, energy utilities, government, emergency services, health, information media technology, insurance, financial services, manufacturing, mining, oil and gas, professional services, tourism, service industry, trade and transport. So we've done similar categorizations in many different forums. Seen from one way, I think sorry, I should have gone to the next one. In this, these categorizations, I think, do focus a lot on services and also the fields that impact industry and economy. Now, this is just a chart of the work they've been doing. So they always annually work towards this annual meeting of Davos. So we are now in the second cycle. And I am hoping to work with the World Economic Forum that's newly established a representative for space. I don't know if Hazuki-san's here. She's back there. So they have a space dedicated contact now in Tokyo. So to work with them to highlight even more at the Davos meeting, what we're doing. And towards that, they've been publishing reports and white papers. Two of the publications that they have done that are cited here are the AI, the catalytic potential of artificial intelligence for Earth observation report, and amplifying the global value of Earth observation report. Both are very concise in their summary, but also extensive in content. It's about 50, 60 pages. So if you go into the details, you will learn a lot. And also there's a lot of literature behind it that you can reference. Next is to show the community that they've been trying to involve. Many of them probably familiar to us, although if you go to the business side, maybe some of them are a bit new, like the banks. Citibank was in one of the meetings I was in New York. We discussed potential use for ESGs, investment, TCFD, TNFDs, and they were extremely interested. They said they would pay, I don't know if it's true, but they would pay a lot of money if this kind of data was available, handy available, they would say, like if it was indexed and available for them to use in a very convenient way, they would like to use it. Right now, they don't even know it exists. So the gap between the users and the amount, the petabytes of data that we have, this is still exists today and something we, after decades, we still need to address. So just to introduce some of the literature also and the blogs and reports, I just introduced the latest, which is Amplifying the Global Value of Earth Observation Report. If you go to this link on the top, and I'm sure the Secretariat will share the presentation. The Earth observation website for the World Economic Forum shows this report, and also AI, and then more storytelling thing, and also a net zero report that the thing that we initially worked on and had quite some impact to some of the decision makers, and also we delivered a highlight report of that to COP28 last year. So this kind of a voice from World Economic Forum, I think, is very much helpful. I did work as part of most of these work, but in our very busy everyday life, and as the Washington rep, we are also working on boots on the moon. So it's quite hard to do, although the manpower of the resources of the World Economic Forum is amazing. So I actually was amazed when I went back to this global evaluation report of Earth observation, how much work has gone into it. We initially tried to do this like 10 years ago at JAXA, kind of miserably failed because it was not our expertise to do this. But this kind of valuation work is very, very useful. Also, they do a assessment on how Earth observation is being contributing to SDGs. Many of us have done it, but not in a way that the World Economic Forum has done it. So I really think that it's worth having a look at. So it was, today I could just go through the overview and point you to where the resources are and where a potential advocacy could be made through the World Economic Forum. I would like to introduce the contacts. Valentine of the World Economic Forum, and also Hazuki Mori, who's attending here. She's based in Tokyo. Thank you so much.
So thank you so much, Onoda-san. Considering the influence of World Economic Forum and seeing the recent developments, I think we also encouraged by this movement. And Hazuki-san, you just raise your hands. So she's the new rep for the World Economic Forum in Tokyo. So she's dedicated for space, and that's very exciting development as well. So maybe you can work together with her. So now I would like to move on to the most exciting part of this event today. So we're going to have a panel discussion between the four prominent speakers, Dr. Saint Germain, and also Professor Atsushi Tsunami, president of Sasakawa Peace Foundation and CONSEO chairperson, and Dr. Kimitake Nakamura, deputy director of the Ministry of Foreign Affairs of the European Affairs Bureau. And I would like to ask Osamu Ochiai to moderate this session. He's the senior administrator for Satellite Applications and Operations Center. So, yes, go on.
Try not to forget anything else.
Okay, yeah.
All right, I'm supposed to be the.
It, all the panelists. Tsunami sensor here, Karen Saint-Germain here, and then Dr. Nakamura here. Thank you very much. Okay, all right, great. Let's get started about the panel discussion. So my name is Osamochi again. So I'd like to start up as a couple, 2 slides only, just introduce about the reminding us about what's happening on Earth in these days, actually. Just showing about a few disasters cases, as you know. Just in Japan, you know, we have a big catastrophic earthquake has happened in Noto. That was still ongoing about how we can recover about that. And then you know that we have a lot recently on the Brazil floods and the Middle East, Dubai, unprecedented rain has happening, and then in the Taiwan's earthquake, Kenya floods, and Greek heat wave, and then Karen, you explained about the last week on the heat wave in the Greece because you were in the Greece. So next slide, please. So that was, you know, you are feeling about these kind of things every day. So that was in our experiences. So this is just also showing about WBON reporting about how much disasters numbers has already increased. Interesting about in the last 10 years was so not so much high, but maybe in the next 10 years, we will meet more increasing disaster will be happen. So these are kind of a food for thought. You already have heard about 2 big, presentations that has already been increasing your insight in your brain. So, but we would like to discuss among our panelists in deep dive for our thoughts on what climate change has happened recent days and what Earth observation play a role and what Japan is playing a role. So these are big 3 questions to be asked. I already saying about the questions, but so I'd like to firstly ask Dr. Tsunami Sensei about what do you think about your perspective on the climate change? Very big, generally asking about what is your expertise on climate change is recent days?
Thank you very much, and that was such an inspiring presentation by Karen. And the fact that you started off with the NASA, that the planet that most studied is the Earth. And that's a very strong message. And I think JAXA should carry that message as well. I think the planet that we study the most should be the Earth. And, because I'm saying this because this week, Japan is hosting the Palm 10, which is the Pacific Island States Leaders Summit. And at least over the last few days, I met maybe 5 to 8 heads of these island states coming to Japan, and including like President of Tsubaru and other small island states. And we all talked about climate crisis. I mean, this is a serious matter for them, right? And sea level rise to ocean acidification and the fish stocks the depletion of the fish stocks and unpredictability of the climate and natural disasters and so on and so forth. And what can we do, right, with them? And my answer is, of course, to work with the United States on the climate crisis and deliver the knowledge that we have and make sure that these island communities have some hope for the future, right, for their life. And so I think, of course, Earth observation is a serious business, and particularly not for the economic and business communities as well, but for the people actually facing this kind of a crisis. And then next year, Japan will be also hosting a TICAD, which is the, I'm sure maybe that foreign ministry is doing this, but with the African states and Africa, Pacific Island communities, small island communities of the world, these are suffering most from this. And the second point, I think, from your presentation, which is very inspiring and encouraging, is the oceans. And I was very struck by the NASA's emphasis on the ocean science and understanding the oceans as this right now the current top priorities of your research, because as you know, the United Nations and UNESCO designated over this year as in the midst of UN Decade of Ocean Science, and I'm a co-chair of the Japan Committee on this. So this is very important that we can share our knowledge and understanding the oceans, and this is something that also for the Pacific Island states. So.
Thank you very much, Dr. Tsunami. I think it was great. You have an ocean expertise that is really new engagement with the NASA. As a NASA is a priority for the ocean this year, actually. So next question is, same question to Karen about what's your perspective on climate change? And you already provide a lot of examples, but do you have any additional insights or we need to understand about how the climate change is ongoing generally? And then see what we need to think about to understand more about that.
Yeah, I mean, it's an enormous question. I think the broad science of climate change is well understood. The impacts that we're seeing now are very, very consistent with what has been predicted for decades. What is more challenging is, so that means, that when we talk about the global average temperature and those and the general trends associated with precipitation and drought and so forth, those are all consistent. But of course, what people are demanding today is far more targeted information on how climate change is going to affect them where they are, because nobody is going to experience climate change as an average 1, 2, or 3 degree temperature increase. In fact, when you say it that way, it isn't compelling to anyone, because we all experience temperature swings over the course of a day that are much greater than that. So it's hard when you talk about global average temperature increase to compel action. But of course, what we need is action. And that means tying climate change to the way it's going to play out. Of course, for the island nations, this is largely sea level rise, exposure to storm surge, salination of their water supplies, those kinds of things. But when I talk with farmers in the Midwest United States, they're concerned about very, very different things. And in many cases, the way to reach them is to talk specifically about what's impacting them, where they are. So getting to local predictability on scales that are meaningful to people, not 50 years from now, but 5 years from now. Today, as you said, it's here. Today, weeks from now, a few years from now, decisions they have to make on the time scale of infrastructure and adaptation. That's really what we're thinking about in terms of driving the strategy forward, is how do we get there?
Great, thank you very much. So yes, thank you very much for your more locally or more end users focusing on how the science-based data can be utilized for that. So next, Dr. Nakamura. So please, because you are coming from the Ministry of Foreign Affairs, so what do you think about because you are much more centralized how Japanese government to work for the climate change, but what do you think is of importance for the climate change?
Okay. Our primary role within the Japanese government is to prepare meetings for the Prime Minister, also for the cabinet ministers. I do myself lots of bilateral meetings with at this juncture with European countries primarily. The number of the items to be discussed within the international community, bilaterally or multilaterally, I think that number of the cases in which we deal with the climate issue, global warming, etc., is increasing. It's quite tangible. That's why, as was mentioned by Dr. Tsunami, this particular week, we have had the Palm 10, in which we gathered as many as 12 or 13 head of states and the government leaders from the Pacific Ocean countries. They also, our Prime Minister has had a number of bilateral meetings with individual head of states at the Prime Minister's office. I attended one of them, which was between Kishida-san and the president of the French Polynesia. And of course, in the course of the discussion, the topic of the climate change was taken up quite naturally. So, so working in the diplomatic sphere, we do observe the growing concerns and interests on the topic as well.
Great. Thank you very much for government is much more interesting about this, how we can tackle the climate change. Okay, maybe next question is, so we are now understanding about the importance for the climate change, what to do. So what we should do, what humankind, largely what humankind should do, but we need to much more focus on what we should do. Maybe firstly, yes, Tsunami-san, please go ahead to your idea.
Well, I think that's one of the reasons we created CONSEO. I mean, get the people know more about the Earth observation. I think that's the World Economic Forum is a great job of making understand the value of a lot of investments in this area and participation of the private sector and whatever. But I think the other thing that Karen mentioned that is very important is the idea of transparency, because this is all about data and making data available to the people that they actually need today. And as we move more towards localization of the data, presenting the data to the people that are necessary, that are in needs, typically from developing countries, for instance, which they cannot afford of their own Earth observation. This is the role that Japan, United States, European countries are necessary to work together to make sure that this transparency, the data that is not a fake, that is scientifically driven, right? And we have to provide the trust in the data, and that's why U.S., Japan, and European nations are responsible to provide this kind of a data availability, and that's the role of Japan. It definitely should be, and of course we love to see boots on the moon or explorations of Mars and all these things. This is all exciting stuff, but the problem that we see here on the Earth is the way that Earth observation is the solution. So I think this is something maybe Karen wanted to follow up on.
Yeah, just please go ahead, Karen.
Yeah, I couldn't agree more. And yeah, again, there's so much to say in this area. I will say that when I speak, I more often I will speak to scientific communities, increasingly more public, but still, most often I speak with scientific communities. And one of the things that I talk about with my fellow scientists is that for decades, the science community has been speaking to itself. We speak in our own language. We publish in our own journals that are impenetrable to people who are not us. And then we don't understand why the world doesn't understand. What Masami said, what we do and how important it is, or at least how important it could be. So we, and I know Japan and I know Europe are working on new ways to connect. The World Economic Forum is one really important way. Our other agencies in our respective governments is another important way. But there's so much work to do. It's going to take all of us. So that means the nonprofits, the NGOs, the private sector. Now, when you involve all of those interests, let's be clear, this is not easy. Especially when it comes to the openness and transparency and meshing those interests, global good kinds of interests, with commercial interests, right? And how do we make those compatible? And I don't mention that because I think it's impossible. I mention it because it's not easy and obvious, and we actually have to tackle it. We actually have to work together, engage in dialogue across the public and private sector to think through how we can make this work for everyone.
Thanks for your interesting, difficult situation to expose. So, Dr. Nakamura, could you please, maybe more specifically, because you are coming from government, how Earth observation community can get close more with government, not probably in Japan or maybe across the world. So, in order to make things more happen, contribute from the Earth observation community to more climate change.
Okay. I think JAXA people are already deeply involved in the international cooperation in this field. So you don't do this alone already. That's why it's part of the international endeavor already. But given the political nature of the issue in the diplomatic arena, whenever we talk about the international cooperation on the global warming issue, always we run the risk to be politicized pretty much. That's why when things tend to be politicized, it is quite important for us to be based on scientific evidences to the extent maximum extent possible. So in order for us to be objective, capable enough to convince the people based on the science, I think the data gathered through the remote sensing capabilities is crucial, very crucial. That's why I think the NASA and the JAXA cooperation are making good outcome in this respect. They also, I feel that it is always there is always room for improvement in terms of the capability of the dissemination of the data and also the narrative to explain to the general public about the significance of the data. So, for example, how to interpret the specific data, how to make the general public understand well the significance of the data. That sort of things are quite important. In this respect, I believe that the interaction between the scientific community and the government section, especially the diplomatic affairs sections, are quite important in order to improve that sort of the efforts.
Thank you very much. Yeah, you touched on a quite important point because we are not building a satellite. We are acquiring a data, we are processing a data, and we also transmit and disseminate the data to the users. But we still need to work for the interpret that how the data can be used, really used for that. This is still maybe one last mile. We are still struggling about this. So by you're saying about the international cooperation is quite essential, but what for? What for to? Because we have a lots of problems. You made a very challenging, very difficulties, lots of aspects. In order to improve or enhance about the cooperation, international cooperation between Japan, US, Japan, Europe, US, Europe, what one of the things you might think of importance away for that?
Well, there are so many things that are important that we can cooperate and collaborate, and but I think today the focus is on climate crisis. So, Earth observation is for private sector and communications and other use that are already being applied, and the rule-based management or governance of especially this utilization of the space is going to be. I mean, we all know that satellites are already too much out there, and we gotta take care of those how we can utilize the limited space of space, right? And this is, I think, it's going to be a very tremendous challenge that the U.S. and Japan and Europe that can think together in terms of creating this kind of rule of how we can utilize the space more accessibly, freely, and openly. But The other, I'd like to mention this is for the climate crisis. I think the Arctic is a very important area where we need to be working together, especially after Russia's invasion of Ukraine. The continuity of data collection without Russia is very challenging for the Arctic observation. And that's something that we have to step up, Japan and the United States, to make sure that we continue to study the environment of the Arctic, and also what I call it the third polar issue, which is the melting ice of Himalayas, for instance, and that creates a natural disaster for the neighboring countries. But the neighboring countries are difficult countries. We're talking about Pakistan, India, we're talking about Bangladesh, we're talking about Afghanistan. I mean, you cannot ask them to cooperate, although they are sharing the very immediate problem of managing their environment. So this is something that Japan and the United States and Europe can come together and then present the kind of a scientific database and knowledge to provide these area of the third polar crisis. So that's another area maybe we can cooperate. Yes.
Thank you very much for your very concrete idea on given the situation about the kind of a real geopolitics, but I think it's great to know that. Karen, you have some ideas what really concrete we should cooperate I mean, way forward.
Yeah, I think that okay. So we know that we are going to have to continue to observe the Earth in many ways, many aspects: the water, the atmosphere, the Arctic, the Antarctic, the oceans. That's a lot of continuous observation, and so I think one very concrete way, and this does happen through multilateral organizations like CIOS and CGMS, but coordinating and collaborating and considering these as a global constellation to which we all contribute and from which we all draw, I think is the only way to meet all the needs. Because no one country, no one continent can do it all. So I think that longer term planning together, likewise collaboration on you mentioned it, the extracting information from the data. People don't need data. The world is drowning in data. What they need is information that they can take action on. And today we do a lot of that independently, and there's a lot of inefficiency, or I will say repetition in the system. Some amount of that is good, right? Some amount of that helps propel the field forward. But we could be a lot more open with our algorithms and our data sharing and so forth to accelerate and expand the impact. And then maybe I'll save this for a later question, but I do want to come back to, at some point, the fact that at the end of the day, we're still dealing with people, and we have to recognize we're dealing with people. They're not machines. So throwing data at them is not how you get the answers.
Nakamura-san, do you have any ideas? Because we are talking about maybe NASA, JAXA, we have been a lot for the cooperation in the past, but and the way forward, we will still need to currently provide some sort of ideas. But for the government level, do you have any ideas on any cooperation for Earth observation? So,
I'm not part of the detailed discussion between NASA and JAXA and other space agencies. That's why. Yeah, there might be always room for improvement for the cooperation, but in my view, one of the biggest missing pieces for the successful application of the space assets in coping with the global warming issue is more active participation of the business community. obviously, the operation and the establishment of the space assets for that purposes should be based on the governmental affairs. But it is my understanding that the outcome of the remote sensing activities could be used for commercial purposes as well. Also, the governmental sector can procure more sophisticated services from the private sector in order to improve the quality to be provided to the clients, including the developing countries. That's why I would like to suggest to explore more the way to engage more the participation of the Japanese and the American business communities for that purposes. In this respect, I think the G2G talks between Washington and Japan and other spacefaring countries might be quite effective because there might be lots of good practices in this respect.
Thank you very much. Maybe Karen, you want to follow?
Just want to build on that. First, emphasize the importance of what you just said. I think that is absolutely true, and I think in the U.S., earlier you mentioned the political nature of climate change. I think in the U.S., the engagement with businesses is part of the key to moving past the political divisiveness of the issue.
I think that's a great idea because always when talking about the NASA JAXA, only just a public perspective, but we need to definitely about talking about how we can cooperate with more business in cooperation. That was a great idea. So I hope this would be help from the government push. So that might be great. All right, still we have a time. So do we have any questions from the audience in the room or maybe in the online? So. Okay, so if you have, maybe, okay, yes.
Okay, in English. So this earlier this week, I was in a workshop with local governments in Japan who had experienced the Sendai earthquake and also who are dealing with the aging society and the lack of bus drivers and all of that. They were saying, so in the end, we get phone calls, we have people to rescue, and on the other hand, you have all these. You tell us you have all these data. And so the shorthand question was, what do we do with this? And you know, we've been tackling with this kind of, so we have pilot projects and all of that. And they have NGOs that help that. They have also startups that try to help this sort of thing and also try to standardize this kind of information so that it can be shared afterwards with the local governments, between the different local governments. But all of that, it seems to be very hard for them with their shortage of personnel also in the local governments. And I was at a loss what to tell them. So we being kind of up here, they being down here with the real problems, and we talk about all these disasters. If you were in my position, what would you have told them?
Maybe I will defer to first week, Karen, if you can provide some.
Yeah, so there, I can give you a few insights, but first acknowledge it is a really difficult problem. The idea of making information actionable at the local level is an extremely challenging problem for organizations like JAXA or NASA. We don't have the ability to have interface with every community that could benefit from our data. So we have to be very strategic in selecting partners so that we have one interface and that partner has many interfaces to amplify the impact of the work. So that's so partnership is the only way to have that kind of local impact. And the second thing I would say is co-development of the solutions. For many years, earlier I talked about how the science community talks to ourselves a lot. Well, we also like to design solutions inside our own scientific bubble and then present them to the world. And we know that that doesn't work well. So we have moved at NASA, we have moved to a model on the Earth Action end of our portfolio. We've moved to a model of co-development with, I'll say, representative users. This doesn't work for every case, but it works for the middle 80%. The idea is to work with a typical user on a solution and that actually addresses their problem, and then try to work with partners to scale that. But the co-development piece is important. Otherwise, we end up throwing data, throwing tools that are not compatible with the decisions they have to make.
Great, thank you very much. I think this is a really important. JAXA is also struggling about to reach out to the real end user community, so that we have the same challenge. So I think it's now almost a time done, but I just only have one quiz for you. Do you know how many Earth observation satellites in fly? Maybe Karen knows about it, but I'm just three options: 100, just a rough scale, 100, 300, 500. What do you think? First option, 100. Raise a hand. 300, 500. Roughly 300 in operation, more to say 365 in our databases, but not including a commercial satellite, of course. Sorry about that. It's just only for the public satellite, not including a planet or other. But we are also planning about 150 planning to launch at this point in time. So as you said, how we can coordinate into such a big numbers of the satellites. So that is quite important. So that's only my last things to say. Thank you very much.
Hey, thank you so much for the panelists for this very exciting panel. And now I would like to ask Dr. Riko Oki. She's director of Earth Observation Research Center, and I think she's the best person because she is the first Japanese person to be awarded NASA Administrators Agency Honor Awards for her contribution in Earth observation. So, Dr. Oki, may I ask you for the closing remarks?
Thank you, Sugita-san. Okay. Thank you for participating in the Climate Change Series event hosted by the Satellite Earth Observation Consortium, CONSEO. We also extend our sincere gratitude to the experts who took the time out of your busy schedules to share your insights. Thank you. So today's event marked the first step in understanding and addressing the challenges posed by climate change. Together with the experts, we explored these issues from the perspectives of earth sciences, national security, and socioeconomics. As we conclude, I would like to address a few words as a representative of Japan's core agency for Earth observation research. So climate change caused by human activities impacts the Earth systems, leading to extreme weather and ecosystem destruction, significantly affecting human society. To address these challenges, it's essential to understand Earth's processes. For example, in Japan, we recall the intensification of water disasters due to very heavy precipitation caused by so-called Senjō Kōsuitai in Japanese. So to understand the mechanisms of precipitation, we need to observe various physical phenomena like the atmosphere, clouds, convection, and precipitation globally. For a quarter of a century, Japan and the United States have been working on precipitation observation from space, as Karen-san introduced. So accumulated observation data has advanced research on precipitation mechanisms, improving weather forecasts. At the GPM 10th anniversary symposium this afternoon, we will showcase the scientific achievements and societal applications made possible by satellite observations. We hope you will understand how satellite Earth observation aids in understanding the Earth processes necessary for climate change measures. Global Earth observation enables us to understand climate change mechanisms and project the future accurately. With this scientific knowledge, people can develop and implement appropriate measures to tackle complex challenges like climate change. Understanding Earth's processes cannot be achieved by one country's science and technology alone. It's essential to increase observation capabilities from space and continue advanced observations through collaborations such as the Japan-US cooperation. Furthermore, based on improved projection accuracy through the understanding of Earth's processes in executing climate change measures like mitigation and adaptation, partnerships with the industrial sector are indispensable. We aim to not only continue our research on Earth processes, but also collaborate with industries in taking action on climate change measures. Today, we learned about international climate change concerns understanding and countermeasure examples, considering Japan's role in the international community. Through the Climate Change Series program, we will continue to advance the engagement of academic research insights with actions for addressing climate change and evolve the partnership with various stakeholders. That's all. Thank you.
So this marks the end of the program, and thank you so much for your attendance. And I hope we're going to take next actions as well as continue this initiative. So I hope you'll be engaged in still become connected to our initiatives. So please stay tuned. So thank you so much. And again, applaud for the speakers. Thank you so much.